Okay, guys, so we're in Gizmos right now. And so you should have your Gizmo open and launched so you can see it. And then you should also have your document from the assignment open so you can type. And there's a way to have this as a split screen so you can view your Gizmo on one side and view your document on the other if you need to. The best way to do that is to put these in two different windows, not tabs, but windows, and then have one window on one side of your screen and the other window on the other. It's not that necessary. You can still toggle between the two. So you could look at the gizmo, do what you're supposed to do, pause it, go to your document, type out what you need, go back to the gizmo. And that works too. That works fine. So however you would like to do that, that's what's going to be best for you. So this is our document that you're going to do for the Gizmo. And I know that in the past, we've just given you Gizmo documents, and you might have been confused about how to answer some of the questions. So I'm going to walk through the document and just kind of show you how to go about finding those answers so you can complete this Gizmo lab for 25 points and you can do well on it, because I think it's very important that you guys have success. You're very capable. You guys work hard. Most of you have turned in all your work all year. And I've really enjoyed teaching my sixth graders. It's been refreshing. And so that means that I want to continue to see that success. Okay. So when you get in here, there's always going to be some prior knowledge questions, and there's always going to be a list of vocabulary. And so these are words that you may or may not know. They're usually defined in the experiment themselves. Some of these vocabulary words aren't in here because I took out this section where it talks about kinetic energy, for example. And a lot of that is because diffusion is a really cool scientific thing, and we can use it to learn a lot of different things depending on what we're focusing on. We're going to learn specific examples that apply to something that we're going to do later this week. And that's just important because it's important for us to have a purpose in what we're learning so we can use it in the classroom. And so that way we can understand that when we learn new things, we always have a purpose in what we do with that new knowledge that we learn. So the first question is talking about microwave popcorn and that smell. You know, when you walk into a theater, you don't want popcorn necessarily, but the moment you walk into the movie theater, you're like, I need popcorn, Dad. I need popcorn, Mom. Like, I'm going to steal the popcorn if you don't buy me popcorn because I smell it and I have to have it. Right. So it's just asking a question about that and kind of your reaction to it. Okay. And then there's a warm up. And so the warm up is designed to help us understand how the gizmo works. And so the description talks about smells. And then for the warm up, we're going to actually go to the gizmo. And so the gizmo, well, I need to log in because it thought I was a guest. So if that happens to you, you'll need to log in. And the gizmo is going to look like this, right? And so when I go to the gizmo document that we have, oh, here we go. It says click play and observe. And observe means to watch. So we're just going to click play and watch what happens. Okay. Cool. Yeah. Whoop, whoop. And then I'll hit pause. And pause means to stop. And I made some observations. What did you see, hear, smell, taste, touch? Okay, well, mostly see, right? So we're making observations with our eyes as we watch this. And we're going to go back into our document and answer those questions that deal with it. So describe the motion of particles. You're going to tell me what happened over time, what's happening. So over the course of time, the longer we watch, what is going on. And then number 3, it says select, then it talks about what diffusion is, and it says select the bar chart tab. So we're going to go to diffusion, and it says, oh, bar chart, and there we go. And now I can see that these are about actually the same amount of particles in both sides, right? And so I can go here, and it's going to say, observe the chart for a few minutes. After the first 30 seconds or so, how much do the numbers and the particles of each region change? So we're going to go back and probably have to do that again, right? We'll go here, since it's frozen, we'll click reset, and we'll just, instead of watching this, the particles, we're going to watch the bar chart and we'll hit play. So as we hit play, what's happening to the bar chart, that's kind of showing us what diffusion really is, right? It's the movement of molecules from one place of high concentration to a place of low concentration, right? So we'll go back and we're going to write our answers. So when the numbers don't change much, the particles are said to be in dynamic equilibrium. So equilibrium sounds like it means, you hear the word equal in it. So it's when a substance is not changing, it's at equilibrium. So the reality is in nature, it's always changing, but it's changing at the same rate both ways. So it doesn't actually change overall. It's kind of like we're always making decisions and stuff, but we're still who we are, right? So we're going to click pause and then select the graph tab and then say what does the graph tell us about it. So we can click on the graph. Okay, what is going on here? Well, it talks about percentage. So your answer probably should talk about percent, right? And then right here it says particles in region A, and then particle Y in region A. Well, there's only one particle we're looking at, and that's particle X for this experiment. So when you go down here, we're going to start kind of our real experiment now that we know how to use it. So how do factors other than temperature affect the rate of diffusion? That's the main question. We didn't talk about temperature that much, and we could have, but I kind of wanted to wait on that. But temperature is the movement of molecules. So if these molecules are moving faster, they're going to diffuse faster. They're still diffusing like normal. They're going to go from where there's a lot of them to where there's not a lot. But if you heat them up, they're going to move faster because heat is energy and energy is speed. So that's just going to happen quicker. It's not anything new is happening. It's just happening faster with temperature. But how do other things affect diffusion? So number one, we're going to pick the wall as the variable. And so originally it said to pick any variable. I want you to change the wall. And so you might say, wall, well, what the heck is that? I don't know what you're talking about, Mr. Smith. Well, that's this orange pink thing right here in the middle. And we're going to reset, and you can decide how big you want your wall to be. You want it to be the Great Wall of China, if you want it to be a picket fence, I don't know. And you're going to just record the percentage of that in your lab. Every one of you could have different heights. It doesn't matter. But you're going to take this experiment and you're going to pick the wall. And then how would that represent the distance of the coastline on a beach? So we're trying to apply this to a specific situation. So when I say coastline on a beach, you have the beach, which is sand, and then you have like where everybody lives. And so there's plants and animal life, and there's streets and hotels and homes and all that stuff. So how does that wall represent that beach from the coastline where the water is to where all the living things are? How can that represent that? That's the question, right? Number two, how do you think changing the wall will affect the speed of diffusion? You're going to write a hypothesis. And so it's an if-then statement. So you're going to type where the blanks are your words. If we change the height of the wall, or if we increase or decrease, however you want to talk about that, then the rate of diffusion will increase, decrease, it's going to get more, going to be less, right? Just a hypothesis. You're just going to say, what do you think is going to happen, right? So number three is your setup. So you're going to put that percentage for the wall in there. If you want to keep it easy, I would leave one of them at 50%. But we've already seen what happens at 50%. So I would go one of your walls below 50 and see if that changes anything, and do one of your walls above 50 and see how that changes things. And then you could find out kind of how diffusion is affected by distance here. Number four, you're going to gather data. And so you're going to time how long it takes to reach equilibrium. So let me show you how we're going to do this. If I can hit play, and then I'll just go to reset. And I want to go back to where I was. It's 50%. Everything's on A, right? I'm going to change the wall. So I'm going to go down to 25%. So we're going to say there's less beach here. The distance between the water and the living things is less. And so what we're going to do is we're going to hit play, And when we do that, I'm going to look at the bar chart because it's really easy to see when this bar becomes equal on both sides. So I'm going to hit play, and you can see there's a timer right here. And I'm watching to see when those two purple lines become the same. And I'm going to pause it. So right about here. Look, they're pretty much the same. Not perfect, and it took 69 seconds. Okay. So I'm going to go into my worksheet, and that's where I would type right here, 69 seconds, right? And I'm going to do it again. I'm going to do it 5 times. So I'm going to go back to my Gizmo. I'm going to hit refresh, and I'm going to do it again. 38 seconds. Well, that was even faster. So maybe I waited too long the first time, but we'll see. And then I would type in right here, 38. Okay, I'm going to do it 5 times. Okay. And then for setup B, that's going to match up here. Let's say for this one, I did 25%. And for this one, I did 75%. So I'm actually going to make the wall bigger. So for part B, I can go in here. I can click reset. I can move this wall to 75. Or you guys can pick wherever you want based on your data. And I'm going to hit play, and I'm going to see how long does it take for this to get to equilibrium. And I'm basically looking at those bars, and I'm seeing when do they get even. And it doesn't have to be perfect, but pretty much close. So that's close. So 211 seconds. Wow. All right. And then I would go in here and I would type that in here for the second data, 211, right? So eventually you're going to get all of that information. And then the last 2 questions, you're going to actually find the average. And then you're going to compare those two and talk about how changing the wall affected diffusion. So if you don't know how to find an average, there is a link here to a YouTube video that's real short that just shows you again how to find the average of numbers. And so if you're not quite sure how to do that, you can click there and watch that. But we're going to find the average of set A and set B, and then we're going to compare our data because that becomes our data. So we're going to compare A and B, and really you can compare it to before we had that 50% wall. So make sure one of your walls is less than 50% and one of them's more. And you can talk about how increasing it made this change and decreasing it made this change. That's what we really are looking for. So how does it affect the rate of diffusion? And then why do you think that happens? So that's where you actually, if you're thinking like CER conclusion, that's like our explanation, right? So that's where your reasoning would be. So you're going to say because, you're going to use that word if you'd like to. And you might say making the wall larger, change the rate of diffusion in blank this way, made it faster, made it slower, because the molecules took longer, or whatever you want to say in your own words. Okay. So that's how to do the Gizmo activity for today. Good luck, guys. Hopefully this will help us understand diffusion. And I really think using the idea of the beachfront is going to help us with our project we're going to start later this week, talking about diffusion and heat transfer and the climate. How does all of these systems, how are they all a part of that? And is there something we can do as humans to help each of these systems survive when you have all these changes? Okay, you guys have a great day. Good luck.